Yes. It is minimize it.
Good.
Okay, where was I? Oh, now there's a thing.
Yeah.
Non-metric unified tensor Einstein supergravity theories in 6 dimensions. Delighted you could join us. All right.
Yeah. Well, thank you. Thank you for the invitation. Unfortunately, I'm not able to travel and give an in-person talk. Hopefully, this will change in the near future. Anyway, I'll be talking about maximum supergravity, conformal symmetry, and non-metric unified tensor Einstein supergravity theories in 6 dimensions. Well, first I will remind you some old facts. Back in 1978, Penn classified the space-time superalgebras and showed that 11 is the maximum dimension for the existence of Poincare supergravity. And in 10 dimensions, we have 2 different types of supergravities, 2A and 2B. They all have 32 supersymmetry generators. And the inequalized supergravity in 4 dimensions was obtained by Kremer and Julia by dimension reduction from 11 dimensions. Again, in the same paper, Nanam showed that the maximal dimension for the existence of simple superconformal algebras is d equals 6. And the superconformal algebras in that dimension are of the form OSP H*/2n. And in 4 dimensions, of course, we have the superconformal algebras, the H2,2/n. And restricting to 32 supercharges implies that for conformal supersymmetry, capital M must be equals to 2 in d equals 6 and n equals to 4 in d equals 4. And the general folklore has been that the conformal supergravity series exists only for n equals capital N less than 2 or equal to, or any capital small n equals to or less than 4. Now, I will also remind you some old work. Again, this is later in 1984 in the summer in Aspen. And the work I did with Neil Marcus, we calculated the spectrum of 10D supergravity on a DS5 course S5 by simple tensoring of an ultra-short supermultiplet of H2,4, which is the symmetry of the compactifying solution. This ultra-short supermultiplet is the CPT self-conjugate doubleton supermultiplet that decoupled from the spectrum as gauge modes. And it does not have a Poincare limit in 5 dimensions. And we pointed out that its field theory lives on the boundary of ADS5 as a superconformal field theory. And the unique candidate for this theory is the n equals 4 super Young-Mills theory, which was known to be conformally invariant at the time. So this is one of the earliest examples of ADS-CFT dualities within the framework of cosine line supergravity in a true Wagnerian sense. If I could add a footnote here, since Chris is in the audience, we submitted our paper to Physics Letters B, and the editor sent it back without sending it to a referee, saying that it is not suitable for publication in Physics Letters B. When I called him to ask him why he thought that, he said that there are very few people in the world who would appreciate it. Anyway, it was clear it was hopeless to try to argue with the editor. So we submitted the paper to Classical and Quantum Gravity. Kelly Sell was the editor, and he sent the paper to Chris for refereeing. And Chris told me later that he had already seen my preprint before, so I did not have to read it a second time. So anyway, in the same journal, there was an accompanying paper in which we showed that the fields of CPT self-conjugate doubleton supermultiplet of superconformal algebra H2,2/8 with 64 supersymmetry generators are in one-to-one correspondence with the fields of maximals n equals h supergravity in d equals 4. Well, that was somewhat surprising because this suggested the possible existence of n equals a conformal supergravity in d equals 4, in contrast to existing folklore. However, to this day, no such conformal supergravity theory with the local Lagrangian has been discovered. Interactions in the maximal inequalized supergravity of Kremer and Julia break the conformal symmetry down to its Poincare subgroup. Again, in Aspen with Peter Van An and Nick Warner, we calculated the spectrum of 11 dimensions per gravity on ADS7 cross S4 by tensoring an ultra-short supermultiplet. And we, again, this ultra-short double supermultiplet decoupled from the spectrum as gauge modes, and it does not have a Poincare limit in equals 7. And we point out that its field theory lives on the boundary of ADS7 as a 60-20 super conformal field theory. Now, 17 years later, the work I did with Chiodoroli and Royban, I won't go into the motivations, we asked the question whether there's an analog of H2/8 symmetry related to 4D maximal supergravity with 64 supercharges in 6 dimensions. The answer turned out to be yes. The analog of H2/8 is OSP H*/8 with 64 supercharges. And its ultra-short doubleton supermultiplet reduces to the CPT self-conjugate doubleton supermultiplet of H2/8 under dimension reduction from 6 to 4. It's referred to as 4-0 supermultiplet and is different from the 2-2 maximal graviton supermultiplet of maximal Poincare supergravity in 6 dimensions. 2-2 supermultiplet is not a conformal in 6 dimensions. Now, 4-0 supermultiplet of OSP H*/8 has some novel features. The most novel feature is that let me move this all the way, that the graviton is not described by a symmetric tensor in D=6, but rather by a mixed tensor, transformed like the Riemann curvature tensor in coordinate indices.
Murat, before you go on, a very quick question, if I may.
Sure.
This algebra, OSP H*/8, I mean, it is not traditional type of conformal algebra. Would you agree? It's not like commutator of 2 SUSYs gives rise to only the expected conformal rotation generators. There must be some unusual p-form generators or something. Is that right?
No, it's perfectly kosher as far as the superalgebra is concerned. So symmetry generation clause only is to SO6, 2 and USP8, nothing else. Okay.
Oh, but then shouldn't Werner Nahm find such algebras already?
No, that's in his list. The algebra is in his list. I'll come to that.
In his list, you say.
There may be even higher analogs of this. I'll come to that at the end of my talk. Now, this is a very kosher superalgebra. I'm staying within the
But you agree that when we talk about the quick remark, then I stop. You agree, I hope, that when we talk about, for example, super ADS algebras, the buck stops at 7 dimension, and when you go beyond 7, if you do talk about ADS algebras, you mean that there are extra generators on the right-hand side.
Yeah, if you go beyond 7 dimensions, that's true, yes.
And you see, terminology-wise, is dangerous because some people may say, oh, it's ADS algebra, like OSP 1/32, for example.
Yeah, I'll come to that also at the end of my talk.
Yeah. Okay, so this is a kosher algebra. It's not like analog of...
Perfectly kosher, yes.
Okay, thank you. Go on.
Okay, well, that's unusual. But first of all, it reduces to the gravity. So the n=8 supermultiplet of H2/8 in 4 dimensions, whose fields are in one-to-one correspondence with the fields of n=8 supergravity in 4 dimensions. But in 6 dimensions, here's the supermultiplet. It has some peculiar features. This 4-0 supermultiplet, in terms of, first of all, I should mention that Chris House studied this 4-0 supermultiplet earlier, using the so-called dual graviton formalism in terms of coordinate indices. It's very complicated in that language, but in terms of superhistorial variables, it's extremely simple. Here's the entire supermultiplet. You see, it's antisymmetric in the capital internal symmetry indices USP8, symplectic traceless, and symmetric in the Lorentz spinor indices alpha, beta, gamma, delta. There is a non-metric graviton with a symmetric tensor in the spinor indices of H2*4, which is the Lorentz group in 6 dimensions. And there's a non-metric gravitensorino, and then 27 self-dual tensors, 48 spinors, and 42 scalars. This is a supermultiplet. And Chris House showed that when you reduce the dimension to 5 dimensions, it coincides with the fields of maximal and equal supergravity in 5 dimensions. But the difference is that in 6 dimensions, it's not described by a symmetric tensor, the graviton. Okay, it's a non-metric graviton. It's a mixed tensor. So that's a peculiar feature about
Murat,
it.
although you're writing R, you really mean this is a potential? I'm a bit confused.
No, I'm only talking about field strengths.
But on the right column, you say non-metric graviton, as if it's the field you're talking about. Why
Well,
on the
yeah,
left?
okay, I may be using, I can say, about graviton field strength. I'll come to the fields for it, potentials for it soon. I'll talk about the potential soon.
So the field potential itself has 4 indices, right?
Yeah, field potential, in the way Chris formulated, potential is a 2-2 tensor in coordinate indices. I'll come to that shortly.
Okay, I'll wait. Okay.
Okay. Yeah. Okay, let me continue. Now, okay, yeah, Chris, the way he formulated it, the field strength of the 2-2 tensor is this 3-3 tensor. Okay, in his language, this is the field strength of the graviton, non-metric graviton, 6 dimensions in his language with 6 indices. In our language, there's 4 spinor indices, nothing else. Okay. Now, in Chris's language, you said there is some self-duality constraint on this tensor. The first 3 indices, as well as the last 3 indices, there is this self-duality constraint. Similarly, gravitensorial field strength satisfies this self-duality constraint. Okay. Now, before I go to the potential, I should mention that this can be obtained by tensoring the 2-0 multiple with itself. Now, an interacting superconformal theory of 2-0 tensor multiple is conjectured to be dual to M theory on ADS7 cross S4 by Model-Sena. Witten argued that the interacting theories of 2-0 multiples are non-Lagrangian. So this suggests that the same is likely to be true of the interacting non-metric 4-0 supergravity. Now, before I go to the potential, let me remind you.
If you take the product of 2 doubletons, you should get the supergravity in 7 dimensions, right? That's how ADS-CFT works, right? You take the doubleton on the boundary.
Exactly. Yeah.
So what's the relation between 7-dimensional ADS supergravity versus 6D supergravity you're talking about?
Well, first of all, we don't know how to construct the interacting theory of this thing. So before we go to higher spin theories, I know where you're coming from. We don't know how to construct, but maybe I should answer your question at the end. You know, I don't want to go in the direction of higher spin theories. That's another story in itself. Okay. Now let me tell you, the superspace we're dealing with is ordinary coordinates, which is antisymmetric tensor spinorial indices, and then 8 spinorial corresponding coordinates. All the field strengths that I gave you can be fit into a single scalar superfield with the indices ABCD, antisymmetric and symplectic traces with respect to USPA. Okay, and it satisfies the differential constraint. So it's extremely simple in the all-stated construction. Now, as I said, the dimensional reduction of this supermultiplet becomes a quotient supermultiplet in 5 dimensions, as Hall was showed. What's also interesting is that, as Hall showed, the gauge symmetries of the 2-2 field go over to diffeomorphism invariances in 5 dimensions. Okay, that's quite remarkable. But see, the same theory in 5 dimensions can come from either 4-0 supermultiplet or from the 2-2 multiplet. See, some theories have 2 different uplifts to 6 dimensions, as either kosher Einstein supergravity theories or these non-metric supergravity theories. Now, of course, you know the field content of maximum supergravity in 5 dimensions. You have 27 vector fields and E6 global symmetry. Now, what's special about this going from 6 to 5 is that the Lorentz group in 6 dimension is SU star 4, and the Lorentz group in 5 dimension is USP 2,2. Okay. Now, spinor representation of SU star 4, all the tensor representation in terms of the spinor indices, symmetric, remain irreducible when you reduce from 6 to 5 dimensions. Okay, so that since our supermultiple field strength consists of tensors which are symmetric in spinor indices. They all remain unchanged when you reduce to 5 dimensions. In particular, the non-metric graviton field strength reduces the Riemann curvature tensor without an extra vector or scalar field. Similarly, if gravitino field strength reduces to the non-metric gravitino field strength goes over to the standard gravitino. By the way, okay, let's see. And the self-field tensors go over to vector fields in 5 dimensions. Now, coming to potentials. In the way we formulated this multiplet with Kjödör and Royvan, we introduced a gauge potential with these indices, symmetric in the last 3 indices and an upper index. Greek, these are all spinor indices. And the curvature tensor was given by a single derivative. And then this gauge field had some gauge symmetries, you know. And then I must say a couple of years later, Mark Hainaut wrote to me saying that in his formulation as well as in Crystal formulation, the field strength of the graviton, non-metric graviton, from a 2 derivative of a gauge potential. So I say, is there an analog in our formalism? And in fact, I sat down and wrote it down. Actually, here it is. You know, you can introduce a gauge potential, like 2 gauge potential, whose second derivative gives the Riemann curvature tensor. So these are the analogs of the first order and second order formalism for this non-metric supergravity theory.
These are linearized curvatures, right?
Linear. At this point, everything is linearized at this point, yes.
Okay.
So these two, as I said, the analogs are first order, second order formalisms. Now, 4-0 theory can be truncated to 2-0 supergravity coupled to some tensor multiplets. Namely, you can truncate it to 2-0 the non-metric supergravity coupled to 5 tensor multiplets, 2-0 tensor multiplets, supermultiplets. And they form a coset space shown here, SO5 times SO1 over SO5 plus SO5, which reduces the any flow supergravity coupled to 5 vector multiplets in 5 dimensions.
Murat, I should probably know the answer myself, but I'm a bit, you know, I still have to ask you, sorry. I mean, when you reduce it to 2,0 language, the interactions are presumably known, right? I feel embarrassed. I may be the one who constructed those interactions, but I don't remember.
Wait. No, these are not metric supergravities, please. You have not constructed.
Oh, wait. But when you reduce, you gave a decent multiplets now, familiar multiplets. Why not?
I know, but you can come to it from your side as well.
But if I can come from my side with this multiplets you are giving me, I couple them. Why can't I declare that to be the 4,0? If the couplings are tuned, you know?
No, because 6 dimensions, you are not conformal.
Oh, that's true.
So these are conformal.
So just looking at multiplet decomposition is not the whole story then?
No, of course, you have to, well, that's what the interacting theory. I mean, maybe there's a non-Lagrangian theories, we don't know.
Okay, go ahead, thank you.
Anyway, now, more interesting is actually to decompose this 4-0 supermultiple with respect to 1-0 supersymmetry. Okay, now this 4-0 supermultiple decomposes to a non-metric graviton supermultiplet of 1-0. Namely, there was a non-metric gravitino, non-metric graviton, 2 gravitini, and 1 tensor. And then there are 6 metric gravitino, non-metric gravitino supermultiplets, 14 cell-2 tensor multiplets, or 14 hypermultiplets. So you can truncate it to a theory that describes the coupling of non-metric graviton supermultiple to either 14 cell-2 tensor multiplets or 14 hypermultiplets.
Oh, okay. So this is still non-metric, even for 1,0.
Yeah,
so
exactly.
My question was empty then.
Exactly.
Yeah, sorry, yes.
Exactly.
Okay.
Okay, now, before I tell you, you might wonder what kind of theories they go down to. They will go down to Maxwell-Einstein supergravity theories. That's why I remind you of some of these. They were constructed a long time ago in this work with Sierra and Townsend. This is the just bosonic sector of the Lagrangian of Maxwell-Einstein supergravity. This is the Einstein curvature, and this is the kinetic energy of our vector fields, scalar fields, and then there's an FFA type coupling in 5 dimensions. This describes the coupling of NV minus 1 vector multiplets to n equals to supergravity. So you altogether NV vector multiplets. So capital indices I, J, K go from 1 to NV, the full set. Now, what's remarkable about this theory is that the entire theory is uniquely determined by the C tensor. The only constraint on the C tensor is that it should lead to positive energy, kinetic energy term, and positive definite kinetic term, and unitary theory. And now, among these, if you want your theory to have a scalar manifold which is a symmetric space, they turn out to be related to Jordan algebras of degree 3. Namely, the C tensor in those theories can be identified with the tensor that defines the cubic norm of a Jordan algebra of degree 3. In those theories, the scalar manifold is a symmetric space of the form reduced structure group of the Jordan algebra, which is the invariance group of the norm, modded out by the automorphism group. Now, among those theories, even though it's a matter couple theory, some of them are unified theories. Unified in the sense that there's a symmetry that relates every field in the theory to every other field. That happens only if there's a simple non-compact symmetry group of the theory under which all the vector fields, including the gravity photon, transform irreducibly. Now, this theory is defined by the Jordan algebras of degree 3 that are simple and Euclidean. They lead to unified Maxwell-Einstein supergravity theories. In fact, they are called magical supergravity theories. They describe the coupling of 5, 8, 14, and 26 vector multiplets to n equals to supergravity in 5 dimensions. So the underlying Jordan algebra are simple. They're given by 3 by 3 Hermitian matrices over the 4 division algebras, real numbers, complex numbers, quaternions, and octonions. And these are the scalar manifolds indicated here, okay, for these theories. In addition, there's an infinite family of non-simple Jordan algebras of degree 3 that lead to Maxwell-Einstein supergravity theories with symmetric target manifolds indicated here. Later, Van Perren et al. Classify n equals to Maxwell-Einstein supergravity theories in 5 dimensions with homogeneous scalar manifolds. They did not find any new unified theories among them. So, but remarkably, in 2003, in the work I did with Marco Zaia, we showed that actually there exist 3 infinite families of unified Maxwell-Einstein supergravity theories defined not by Euclidean Jordan algebras, but Lorentzian Jordan algebras of arbitrary degree. Let me tell you what the difference is. N by n Hermitian matrices over various division algebras form Euclidean Jordan algebras, with the symmetric product being 1/2 the anti-commutator. Their automorphism groups are compact. Now, when you go to non-compact Jordan algebras, elements are no longer Hermitian by themselves, but you have to multiply by a metric, namely eta times x is Hermitian, or eta na to the Lorentzian metric with Lorentzian Jordan algebra, as indicated here. Now, we show that the structure constants of the traceless elements of such Jordan algebras satisfy the unitarity and positivity requirements and can be identified with the C tensor of an n equals to Maxwell-Einstein supergravity theory in 5 dimensions. Okay? And the resulting theories are all unified because all the vector fields including the gravity photon, transform in a single irrep of the simple automorphism group of the underlying Jordan algebra, which is also the symmetry of the Lagrangian. Here's the list of these Jordan algebras, Lorentzian. These are, they're rank n+1 Jordan algebras or the 3 division algebra, real numbers, complex numbers, quaternions, and then there's one octonionic one. They're Lorentzian because I said their elements are Hermitian modulo this multiplication by a metric. Because I said they are unified theories. Among these, by the way, 3 of them turn out to be identical to three of the magical supergravity theories, namely they have some hidden larger symmetries. There's J13 over the quaternions. It turns out to be the same as the J3 octonionic, and so on. Among these three infinite families, one family can be gauged to obtain unified Yang-Mills-Einstein supergravity theories, namely with the gauge group SUN, namely you can gauge the full, the SUN, symmetry such that all the vector fields become non-abelian gauge fields of this non-compact symmetry group. Now, okay, now again, maybe you remember this one. Now, among the magical supergravity theories have uplift to 6 dimensions as standard Poincare supergravity, describing the coupling of a certain number of vector and tensor multiplets. Okay, but in 6 dimensions, they are no longer unified. These magical supergravity theories. These are the global symmetry groups are listed in the first column in this table, and their corresponding pi-dimensional global symmetry in the last column. So this octonionic theory has with 16 vectors and 10 tensors in 6 dimensions. Now, if there exists an interacting non-metric 4-0 supergravity in 6 dimensions that descends to the maximum anechoic supergravity in 5 dimensions, it must admit consistent truncations to unified non-metric 1-0 tensor Einstein supergravity theories with 14, 8, and 5 tensor multiplets that descend to the unified quaternionic, complex, and real magical supergravity theories in 5 dimensions. This is because the 3 of these magical theories can be obtained by truncating the anechoic supergravity in 5 dimensions. So if 5-dimensional supergravity is an uplift as a 4-0 theory interacting, you can truncate that through some sub-theories such that they descend down to these 3 of the magical supergravity theories. Okay, as I mentioned that, like for example, anechoic supergravity, I should say the anechoic supergravity can be truncated to n equals to quaternionic magical supergravity with global symmetry HU star 6. And that has an uplift then to 6 dimensions as a non-metric 1-0 supergravity coupled to 14 tensor multiplets. Okay. And they can further truncate these theories down to complex and real magical supergravity theories. Again, the global symmetry groups under which they were all the vector fields transform irreducibly in 5 dimensions go over to 6 dimensions as global symmetry groups under which all the tensor fields transform irreducibly in 6 dimensions. Yeah, I won't talk about the hyper story. I'll continue. Now, so here are the magical supergravity theories. They are the order algebra 3x3 Hermitian matrices over the 4 division algebras. Scalar manifolds in 5 dimensions, which is the same also in 6 dimensions, if they have uplifts as interacting theories. And the composition with respect to maximal compact subgroup, that there's always a singlet. So that as a 1-0 tensor Einstein supergravity theories, there is one tensor that's a singlet under the compact subgroup, which is the gravitensor. Okay. Now, what's interesting is that now what this implies that these magical supergravities can be uplifted to 6 dimensions either as Poincare supergravities, describing the coupling of some vectors and tensors, or as non-metric 1-0 supergravities with tensor multiplets only. This is analogous to the anechoic Yang-Mills theory in 5 dimensions, which can be uplifted to the 6-dimensional 1-1 supersymmetric Yang-Mills theory, okay, which is not conformal, or the non-Lagrangian 2-0 conformal field theory in 6 dimensions, which is believed to be describing the non-perturbative dynamics of the anechoic Yang-Mills, a strongly coupled limit.
Murat, can you remind me whether magical supergravities have uplift to 10 or 11 dimensions? I don't remember that.
Well, the first three definitely. The quaternionic theory was constructed by Swafa and Sen. They did not know it in their paper. You can read it. There's no mention of the magical supergravity there, but it is there in their paper. It's
So one of the four magic supergravity.
three out of the four.
3 out of 4. So
Three out
which
of
is
four.
which is the one which is still mysterious?
It's the octonionic one, which we're working on still.
I
This
see.
is the one. These are the theories, by the way, which by Larry Romas tried to discover the higher dimensional origins for.
Mhm,
Did all that great work in 6 and 10 dimensions.
mhm.
Anyway, let's say.
So the 3 out of 4 were all done in the same paper by Sen?
But of course, once you get the quaternion, the others are obtained by truncation or by, by modding out by some discrete symmetry group.
No, I mean the one that are already known.
Yeah, that was
established.
all. Yeah, that's implicit in their paper.
Okay.
Okay, that's implicit in their paper.
Okay.
Octonionic one we're working on, it is horrendously complicated from the Calabi-Yau point of view. But anyway, it's a very complicated story. Anyway, so let's continue. So, but this implies that for this unified Maxwell-Einstein supergravity is defined by Lorentzian-Jordan algebras, there should be uplifts to 6 dimensions as unified non-metric tensor Einstein supergravity theories. Okay, and here are their symmetries in 6 dimensions. These are the Lorentzian-Jordan algebra. These are their global symmetry groups. And the composition with respect to Maxwell compact subgroup. There's always a singlet, as I said. These are the gravity tensors. There are 3 infinite families and 1 sporadic one, okay, in this case. I can continue. Now, I should tell you something about the actions for these theories. Let me write this. Actually, for linearized non-metric 4-0 supergravity, it was first written down by Hainaut and Leco and Leonard. You use the forms of prepotentials, okay? They show that it is like a Poincare covariant, but not manifestly. I mean, to show the Poincare, they have to break the 60 coordinates, in the 60-dimensional coordinate indices into 5+1, with the singlet being time-like. And actions were written out by Bertrand, Holm, and Zaptevin also for the 4-0 theory. They also show that it can be written in a Poincare covariant form, but again, they have to do some split of the coordinate to 5+1. But in this case, the singlet coordinate is space-like, unlike the work of Hainaut et al. Okay. Now, but they also looked at the exceptional theoretic uplift of these of the n equals h supergravity to 6 dimensions as a 4-0 supergravity. Okay. Now, let me remind you of this exceptional field theoretic formulation or double field theoretic formulation of maximal supergravity that was done by Holman Zaptevin. The idea is to manifest in higher dimensions the global symmetries of, say, the 5-dimensional supergravity. Since you have 27 vector fields in 5 dimensions, they introduce a 27-dimensional auxiliary internal spacetime extending the 5-dimensional external spacetime. They impose a section constraint of this form, where ijk and a coordinate indices in the auxiliary space. And then they look for solutions, which can be interpreted as 10-dimensional or 11-dimensional supergravity. And they show that indeed there are solutions that takes you up to 11 dimensions or to 10 dimensions. Okay, I should mention that this 27-dimensional auxiliary space-time they're talking about actually is the one that I introduced ages ago, long before any supergravity was written down in the early days of supersymmetry, that said space-time coordinatized by the exceptional Jordan algebra over split octonions. Now, to construct the non-metric supergravity theories in 6 dimensions from n equals h supergravity, 4, 0, 3, 1, and 2, 2, in a unified manner, Bertrand et al. Find it necessary to extend the 27-dimensional internal spacetime auxiliary by an extra singlet coordinate, y dot. And then write this more generalized section constraint. Okay, where delta ij is a constant tensor that describes the background spacetime. Now, setting this delta dot equal to 0, one has a standard section constraint, which can take you up to 11 dimensions by solving the constraint. On the other hand, if you set delta I equal to 0 as this generalized section constraint, this equation is satisfied trivially. Okay, you can see from this equation. Okay, and then you get a for zero supergravity and then by identifying this y dot with the extra singlet coordinate in the 5+1 split they use to show the Poincare covariance of this for zero theory in 6 dimensions. Okay. Now.
And all this is still linear, right? They did not.
Of course, these are all linear. I should be putting it there.
Yeah, but can you comment on why this formula here cannot be part of a nonlinear formulation, at least at the level of equations of motion? I'm not asking
well,
for an action.
we don't have the nonlinear theory in 6 dimensions, so you're asking too much. 11 dimensions, yeah, 10 dimensions, that's we have the Lagrangians and so on, we can compare, but we don't have the Lagrangian for the 6-state theory yet, non-linear or interacting. It's not even clear if it exists as a local field theory. So anyway, now for you can carry the forms and carries over identically, like you can apply it to the magical supergravity theories. You replace the C tensor of the inequal supergravity by the C tensor of the magical supergravity theories. Okay. Now, if you use the octonionic magical supergravity, this you can find different solutions. One solution takes you to the Poincare supergravity that I can start with Ergin and Henning. Okay, that's one solution. Okay, that's with the Koshub 1-0 metric supergravity in 6 dimensions. Or you can, by imposing the section constraint delta equal to 0, identify an extra coordinate with the spatial singlet in the 5+1 split, you get the what you call the 1-0 uplift of the octonionic supergravity, 6 dimensions, as a non-metric supergravity. Okay. Yeah, you can do the same thing for other magical supergravities. You just have to replace their C tensors with the appropriate one. Don't want to spend too much time on that. Now.
And what is the anomaly of this 1,0, the one at the bottom of your slide?
Oh God! Well, anomalies, by involving this non-metric.
No, metric. You're here. You have a metric.
Oh yeah, I know. But that's but in the metric case, this is the one that we studied.
No, but for 1,0, I don't remember this menu of fields that you give.
No, the standard the gravitational anomaly vanishes. We do not have a problem there, but there could be other anomalies.
Okay.
Remember? Yeah.
Yeah. Okay.
Yeah. Okay. Now, well, again, the same formalism carries over for the entire 3 infinite families of non-metric. Infinite family of 3 infinite families of unified Maxwell-Einstein supergravity is defined by Lorentzian-Jordan algebras. You just have to replace the C tensor by the structure constants of the traceless elements of the corresponding Jordan algebra. They all lift up in a straightforward manner to 6 dimensions as non-metric unified 1-0 tensor Einstein supergravity theories. Okay. But what's amazing is that we still don't know whether these theories have opposite Poincare supergravities to 6 dimensions. Again, the analysis we did for the magical theories, we try to replicate for these Lorentzian theories, it's not obvious, but if there are any solutions. So, I mean, clearly they have uplifts as non-metric supergravity theories, but whether they have uplifts as ordinary Poincare supergravities is not clear. How am I doing with time, by the way?
Seems pretty good to me. 3:40.
Okay. No, okay, well, I went too fast, actually. Now, maybe make some comments on this. Yeah. Let me just skip now.
I'm written in this way. Should I think of this as, what's the total dimension here? Is it 27 plus 1 or what is this exactly?
Well, that's a good question. Very good. You see, let me go back to the octonionic magical theory. As I say, octonionic magical supergravity has the E-symmetries like the maximum supergravity in 5, 4, and 3 dimensions, but they're different real forms. And it has 27 vector fields in 5 dimensions, just like any good supergravity. So auxiliary field, what they call space-time, has 27 coordinates.
Mm-hmm.
And it's coordinatized by the Jordan algebra of 3-by Hermitian matrices, which is Euclidean. And it means positive aging unitary representations. So
okay, but then how is it that they found out there's this extra dimension with this blob, partial blob? That's a single additional dimension, right? Can you remind us what's the quick and dirty way to get it?
Yeah, it is actually, it's funny, it's interesting. And they were also referring to Chris Hahn that, you see, in 5 dimensions, you can introduce central charges. There's a tensorial charge and then there's a singlet charge, K. That's the extra coordinates related to the extra singlet central charge. Okay, yeah, I mean.
Is there another occurrence of this mechanism in other dimensions?
Oh God, I don't know. Well, I'll talk about higher dimensions. If we can go higher with non-metric story, there will be, of course.
Mm-hmm.
Yeah, really, of course. Yeah, I mean.
I was wondering more like lower dimension even, where you can talk about central charges maybe successfully. I don't know.
Well, 5 is very special, actually. 5 is very special.
Okay.
And yeah.
Okay.
And anyway, what did I say? Yeah, again, so now if you go to the quaternionic magical supergravity, which has whose string origin, was investigated by Wolf and Sen, or was constructed actually by them, that you then, instead of the 27 external coordinates, you have 15. Okay. So the underlying Jordan algebra is 15-dimensional, and this is the C tensor of the 3-by-3 Hermitian quaternionic matrices as a Jordan algebra. Okay. So it's just star 6 symmetry. And it describes the coupling of 6 tensor multiples and 8 vector multiples as metric Poincare supergravity. But as a 1-0 tensor Einstein supergravity, it describes the coupling of 14 tensor multiples to 1-0 supergravity in 6 dimensions. Now, okay, I talked about this. Now, okay. Now here comes the really speculative part. Is there any conformal path to higher dimensions? Now, the existence of assuming that a non-metric theory exists as an integral supergravity raises a lot of interesting questions. Are there high dimensional analogs of non-metric supergravity that reduces to the non-metric 4-0 supergravity in 6 dimensions upon compactification? I should remind you that, the Werner-Nahm's classification of space-time superalgebras, spatial isomorphism played an important role. Like SO star 8 is isomorphic to SO 6,2, SO2, is isomorphic to SO 4,2, SP4R is SO 3,2. So there were these very special space-time superalgebras. Now, if you go from Brown 7, as you said earlier, again, if you look for a simple superalgebra in which to embed your Poincare superalgebra, but when 11 dimensions, you have to go something very large, like OS/32R. Okay, and then the algebra then involved the momenta as well as tensorial central charges, ZMN, and then 5 index central charge.
But you had a paper in which you somehow doubled this. Can you comment on that?
Yeah,
why did you double it?
That's true because, well, Witten it's shown that the 11 supergravity is a parity invariant. And OSP1/30 was not parity invariant by itself. So I had to double it and then look at the diagonal subgroup to avoid that problem.
Does the notion of ADS algebra care about this parity question or not?
I don't know. I don't know actually.
So as far as you are concerned, OSP 1/32 is the
Well,
minimum.
we talked about OSP 1/32 cross OSP 1/32, but you can ask, well, is there a larger algebra which you can embed it? Well, you have to go to OSP 2/32, and that already enlarges it. We have that 64 supersymmetry generators. Okay. So you're going to the conformal territory, but instead of going along the parallel, let's go the other way around. Now we said that a 6 dimension superconformal algebra are of the form OSP H*/2n. Now super algebras of the form OSP 2n*/2m exist for any n in any m. Now, if this has 64 supersymmetry generators, so if you ask higher dimension analogs with the 64 supercharges, possibilities are OSP 16*/4 or OSP 32*/2. See, this is different than going the SP line as Tuan pioneered a long time ago. Okay.
You mean
Now,
as far as the conformal generalization?
This is conformal group. You see, SO*4n is the conform group of a space-time coordinated by the Euclidean Jordan algebra of M by N Hermitian matrices over the division algebra quaternions. Then they admit positive energy unitary representations. Right? And they were shown to be causal space-time by Mach back in 2004. Now, I should remind you that the ordinary Minkowski space-times in the critical dimensions are coordinatized by Euclidean Jordan algebras of degree 2 over the 4 division algebras. Okay, so the question is, I mean, instead of talking about, instead of the Lorentz group, we talk about SO9,1. Maybe if you have 2 times, you say SO8,2. Can we discuss some space-time where you're talking about SO*10, not SO5? It's not isomorphic to any SOP, Q type group. So this is all virgin territory. I mean, it's not clear how to make sense of them physically. But algebraically, Witten always argued that 6 is the maximum, or Werner now argued that 6 is the maximum dimension. But if you allow this kind of space-time with the Lorentz group or the conformity of the form SO*2n, you can go higher.
But any one of these candidates you are talking about, all of them at least they have one thing in common, that they contain the ordinary SO2, D conformal group as a subgroup, correct? They had better. Otherwise, in what sense are they a generalization of conformal group, you might ask, right? They must contain the familiar bosonic conformal group in D dimensions. Is that correct?
Well, I have to think about that, which ones of them contain it. I have not thought about it. No, but what I was thinking more about is SO*8, okay? It is isomorphic to SO6,2, but if you consider SO*10, it's not isomorphic to SO8,2. Okay, it's a different real form.
10,2. In 10 dimension, I look for 10,2, no?
Yeah, then you will look at SO*12. That's not isomorphic to SO10,2. But you see,
but why should I accept this as a generalization of conformal group then? It's not, is it?
Well, in the sense that if there are non-metric supergravity theories that are interacting, you may ask, is there any higher dimensional, maximal dimension where you can formulate such theories, which under dimension reduction become kosher supergravity theories?
I see. Okay.
Okay, that is the thing. And I mean, whether one can start interacting generalized superconformal theories based on higher dimensions for multiples that reduce to 4-0 non-metric supergravity, and how they can be related to M or superstring theories are completely open problems. I mean, it could be that you would have to talk about some different phase of M theory. Anyway, well, these are open problems, but I think I will stop here and take questions.
Do you have any questions? Let's try from the audience, physical audience first. Apparently not. And virtual audience.
So, sorry?
From the virtual audience, do we have any questions?
I have gazillion questions for Murat, but I will stop. I've already asked so many. I will stop. It's very interesting. I think there are many, many questions this opens.
Yeah,
But, thanks, Murat.
You're right about there are a lot of questions. I agree. Yeah.
If someday I need your slides, would you be generous enough to provide them? I mean,
Sure, sure.
okay. Thank you.
You're welcome. Yeah.
Well, if there are no further questions, and Ergin can ask his questions directly to Murat, I guess. If there are no further questions from anyone else, then let's thank Murat again for a nice talk.
Okay. Thank you for